Good evening and welcome to the Japan Earth Observer for July 10. This is a news roundup for the past week in space, Earth observation, and geospatial industries in Japan. I'm Robert Cheatham. I run a research and strategy consulting firm called Abaca Labs, and I write the Japan Earth Observer newsletter. Tonight we're going to lead off with the acquisition of Infostellar by Mitsubishi Electric and news from the SPACETIDE conference that was held in Tokyo this week. Mitsubishi Electric acquired all shares of Infostellar. Infostellar is a ground station services company founded in 2016, so about a decade old. Make a product called Stellar Station. This deal will pair Mitsubishi's deep satellite hardware and antenna engineering history and flight heritage with Infostellar's agile cloud-based ground station platform. It's also a milestone. It's the first major M&A of a Japanese space startup from the recent past, and this type of exit represents a real pathway for successful startups to achieve scale through partnerships and acquisitions rather than an IPO in the public markets. Acquisitions don't just help the startup firm, they provide exits for investors and employees. This in turn cycles funding back into the ecosystem and enables experienced startup founders and executives to apply their expertise to new ventures. So acquisitions like this can be very good for the broader ecosystem. However, they can also concentrate power in the hands of large legacy companies that may not support customers or innovate with the same agility that a startup would. So there are trade-offs there. But congratulations to everyone at Infostellar. Next up, this week we had a SpaceX Falcon 9 transporter rideshare launch. This was Transporter 17. On that launch was included 7 satellites from Axel Space. These are Grus 3 Earth observation satellites. The launch went up from Vandenberg Air Force Base on Tuesday. All 7 satellites have reached orbit and are reported nominal status after reaching there. Once fully operational, the constellation will enable daily observations at latitudes above 25 degrees north and will provide a 2.2 meter ground resolution, so kind of medium to high resolution. These are multispectral instruments. They capture the usual red, green, and blue, but also near infrared plus coastal blue and red edge. Coastal blue is a new band for Axel Space. It enables capture of information just below the ocean surface, such as coastal topography and seagrass beds. Seagrass beds are particularly important around carbon capture. The satellite bus that was developed for this was developed with funding from NEDO, the NEDO, the Japanese research organization. Axel Space's previous launches have been individual satellites and demonstrators, so this marks a significant change to a true constellation, increasing Axel Space's ability to capture frequently and to enable tasking captures based on customer needs. Next up is Bull Space. Bull Space confirmed their first orbital success of their so-called horn membrane. There was a launch of an H3 30 configuration test rocket a few weeks ago. This included 6 small satellites. 2 of those were from Bull Horn L and Horn R. One was 20 square meters and one was 10 square meters. So they were sent into orbit in order to test a membrane being extended from the satellite that was designed to increase the speed with which they would deorbit. You usually wouldn't want to send a satellite into orbit only to have it deorbit it, but the goal of this mission was to test how quickly a membrane extended from the satellite would accelerate orbital decay. So Bull had other companies that do Situational Awareness in Orbit, a company called JEO in Australia, confirmed that the membrane was deployed properly, and then another firm, Leo Labs, used tracking data they have to show a significantly faster orbital decay versus a comparable satellite. Bull is saying this is the world's largest membrane target for a mission like this, and it's the first orbital demo of a membrane-based deorbit technology by a Japanese firm. Space Quarters won the IVS Launchpad event in Kyoto for 2026. IVS is one of probably two major startup competitions held in Japan each year, and it might be the most important. It's not only 20 years old, it attracts hundreds of startups each year, it's open to the public, and many of the top firms receive funding as a result. Space Quarters what received the top prize. They were one of 15 finalists. Amongst those 15, there were 3 other space and geospatial firms. The firms were Umi Aile, maritime domain awareness using small, fast, uncrewed boats and satellite sensors. The second was Satellix, very low Earth orbit, orbital technology testing and demonstration platform. And RoboTruck, an autonomous cargo truck startup. Space Quarters, the top firm, won 10 million yen. That's about $65,000 US. They are developing a modular robot assembly system called Daiku that enables construction of structures that are larger than the payload fairing on most rockets would allow. They do this by deploying modular units that then can be assembled into much larger structures rather than launching pre-assembled hardware. They beat out 500 other startups this year. So congratulations to Space Quarters. Another ambitious startup called Ariane Space Systems was just started this year. It's based in Tokyo, and they announced that they're aiming for an asteroid exploration mission as soon as 2031. The technical core of what they're doing is really interesting. It's a propellant-free propulsion system that will rely on the regolith mined on the local asteroid that they reach as reaction mass to steer the spacecraft, minimizing the amount of chemical propulsion, which is the normal mechanism used, that'll be required to get to an asteroid and back. A low Earth orbit technology demonstration is planned for 2029, and ground-based integration testing of the idea for acceleration and collection systems is already underway. This is a super early stage effort, but it's exciting to see a Japanese startup setting its sights on such an ambitious project. iSpace, an established startup, announced that they were launching a new lunar integration service that can handle cargoes up to 500 kilograms. iSpace is partnering with SpaceX for this, and the idea is iSpace would integrate and operate customer payloads on behalf of the customer on future Starship lunar flights, with the first mission targeted for around 2030. This will give iSpace a relatively heavy lift lunar delivery path alongside its existing Ultra Lander program. Earlier this year, iSpace consolidated several lunar lander efforts into a single one called Ultra. That effort continues apace, and this will not change that trajectory, but it will significantly expand the payload capacity for commercial and institutional lunar missions that iSpace can handle. Major event this week in terms of deep space exploration, the Japanese deep space probe Hayabusa 2 arrived at the asteroid Torifune and did a very fast flyby on Sunday. So this is a pretty big deal. JAXA pulled off another deep space mission that was the product of several years of very careful design and engineering, operational excellence, and global collaboration. The Hayabusa 2 asteroid mission was launched more than 10 years ago in 2014. In 2018, the space probe successfully rendezvoused with asteroid Ryugu, collected 2 sets of samples, returned those samples to Earth, and dropped them off in 2020. They landed in the outback in Australia. That was the end of the originally planned mission, but JAXA determined that Hayabusa 2 still had enough fuel left to continue its mission. So they worked out that if they used a couple of Earth gravity assists, it would be possible for Hayabusa 2 to extend its mission and visit 2 additional asteroids. So what happened on Sunday is the first of these 2. Hayabusa 2 made a fast, very high precision flyby of asteroid Torifune. It wasn't really designed for this particular mission, so JAXA had to develop a very careful operational plan and execute it flawlessly to be successful. First of all, the asteroid is only about 400 meters by 800 meters, and Hayabusa 2's sensors were designed for rendezvous and landing on an asteroid, not for a rapid flyby. So they don't have sufficient resolution to take good images from a distance. They weren't really designed for that. So JAXA estimated it would need to fly by at less than 1,000 meters. So if the asteroid is about 800 by 400 meters, and they're flying by at less than 800 meters from the center of the asteroid, that's less than the length of the asteroid. If it's tumbling, they run the risk of hitting it. But I had to get that close in order to take useful images. In addition, it's a very fast flyby. They were moving at 5.3 kilometers per second. That's 19,000 kilometers per hour. It would only have a fraction of a second to capture images. So it would have to fly many times faster than a bullet, pass within a distance no larger than the diameter of the asteroid, and do this 100 million kilometers from Earth. It's extraordinary. So JAXA was able to make trajectory adjustments in the days and hours before the flyby, but the distance is so great that Hayabusa had to be somewhat autonomous during the actual passage, so they couldn't get real-time information. In any event, the mission was successful. They pursued this because they felt like this had applicability as a rehearsal for a planetary defense scenario. Now imagine if we discovered an asteroid that could potentially collide with the Earth and cause substantial damage. We'd likely have to both launch new missions and retask existing spacecraft to study, and then make an extremely precise impact on the approaching asteroid, moving at very high speed in order to alter its trajectory. So you can think of it as this kind of a dress rehearsal for both observation and the potential for striking an asteroid with high precision and high speed. So the flyby passed in less than a wink of an eye, but Hayabusa 2 successfully captured images with all of its instruments: an optical telephoto camera, which you see on the left, a mid-infrared camera measuring temperature, which you see on the right, a near-infrared spectrometer for analyzing materials, and a LiDAR altimeter to measure distance. This was also a collaborative effort. JAXA worked with several domestic universities as well as the Georgia Institute of Technology. NASA Jet Propulsion Laboratory provided access to the United States Deep Space Network to communicate with the spacecraft. Commercial firms Fujitsu and NEC also played important technical roles. Finally, an international network of telescopes kept watch as the flyby happened in case the navigation went awry and Hayabusa ended up hitting the asteroid. It was such a close flyby. If they were just off by a little bit, the chances they would hit the asteroid were not small. That would have been a different kind of planetary defense mission, but they did not. It was successful all the way through. Torifune, now that the Torifune flyby is completed, Hayabusa will next return to Earth in 2027 and June 2028. Each time it approaches Earth, it's going to perform a gravity assist maneuver before heading back out into the solar system. And the next target will be an asteroid called 1998 KY26, with Hayabusa expected to arrive in July 2031. That's not a sure bet. The four ion engines on the probe they provide propulsion, have all deteriorated, and the reaction wheels that are used for attitude control have also had problems. But with luck, they'll be able to continue the mission for several more years and visit another asteroid. Next up, this week, as I mentioned at the top, was SPACETIDE. SPACETIDE's a major conference held in Tokyo each year in early July. It includes a whole bunch of presentations, workshops, and announcements. And one of the notable talks was from Rocket Lab's CFO, Adam Spice, who noted a growing sense of quote-unquote panic and anxiety among satellite operators around future access to SpaceX's transporter rideshare program. Now, I mentioned earlier that transporter rideshare was launched earlier this week, but apparently SpaceX is not accepting new satellites to go on future transporters after late 2028 or early 2029. A lot of Japanese startups, Actual Space, ArcEdge, and others rely on these SpaceX Falcon 9 rideshares to reach orbit. And that's obviously not just Japan. This is critical infrastructure across Europe, North America, Middle East, and Asia. Not only is SpaceX not scheduling new transporter missions, it's gradually reducing the number of Falcon 9 missions as well. I mean, we can imagine that SpaceX will have some kind of similar Starship-based product in the future, but Starship's not yet operational, and we don't know when it will be. So this may present an opportunity for smaller rivals like Rocket Lab, but also Vulcan, Japan's H3, and many others. And we'll see how that plays out in terms of providing launch opportunities. This week was a big week of deals announced at SpaceTide. Before I get to SpaceTide, there were a couple of others that happened beforehand. Chemitox announced that it was selected for a JAXA Space Strategy Fund contract to develop flexible solid-state batteries for small satellites. Chemitox has developed a extremely malleable, flexible, solid-state battery that can be conformed around internal parts and unused gaps in small satellites. And this provides a lot of flexibility for satellite designers to maximize the payload volume as well as add design freedom. There's also the potential to use this in future spacesuits, which have similar kinds of limitations. Space Renaissance and a firm Quantier have announced that they've formed a capital and business alliance. Quantier is a Tokyo-based consulting firm that does flight analysis, mission safety, and propulsion design. They're going to be joining, the CEO is going to be joining the Space Renaissance board to lead commercialization. Space Renaissance is a rocket engineering startup that was founded earlier this year. Look forward to seeing what kinds of details come out of that. But at SpaceTide, Japan and Singapore signed bilateral space cooperation pacts. JAXA and Singapore's newly formed National Space Agency, NSAS, signed a memorandum of cooperation. This is NSAS's first bilateral space agreement. Singapore has also joined JAXA's co-funding arrangement known as the Business Promotion Framework as the third international partner after the UK and France. Underneath this Japan-Singapore agreement, SkyPerfect JSAT announced they're going to be forming a partnership with Singapore's Spectral around quantum cryptography for satellite communication. Warp Space is partnering with Singapore firm Celestial Technologies on interoperable laser links for satellite networks, and Fusic and the Nanyang Technological University, NTU, in Singapore signed an MOU on cloud AI-based ground stations. Fusic is a cloud technology integrator based in Fukuoka. NTU has a satellite research center, SARC, that the two organizations are going to co-develop future ground station technologies. JAMS, the Japan Manned Space Systems Organization, signed a strategic MOU with VAST for private space station market expansion in Asia. JAMS has been around quite a while. They handle manned space system design and mission design and that sort of thing. In this case, they're going to be handling microgravity mission design, astronaut training, and operational payload support. VAST, which is a U.S. firm building a commercial space station, but also has a subsidiary in Japan, VAST Japan, they're going to be expanding their commercial low Earth orbit station operations in the Japan-Asia region, and JAMS is going to be able to help them with that. VAST has developed what they call the Claybox cell culture system that will be part of the first commercial space station that VAST launches, called Haven 1. Space Data, the satellite data analysis firm, has signed a space situational awareness MOU with the Australian firm Innovor Technologies. Space Data has an AI platform that they call SpaceBrain. They're going to be linking this with Innovor's planned Hyperion low Earth orbit constellation that is able to capture information about both satellites and debris in orbit. That's why it's called Space Situational Awareness. They're planning to launch that constellation in 2027. ArcEdge has contracted with the Italian firm D-Orbit for launch services in 2027 and 2028. D-Orbit doesn't actually have its own rockets. Rather, they've created what they call the ION satellite carrier that essentially integrates a satellite inside a engine compartment. That engine, once launched, takes the satellite into a very precise orbit, more precise than what the rocket can do on its own. So D-Orbit will handle contracting that rocket, packaging the satellite into this ION satellite carrier, and will send ArcEdge's satellites into very precise orbits in 2027, 28. ArcEdge's satellites are generally cover a range of purposes. One is around VDES for maritime communications. Second is around IoT, Internet of Things, so communicating with ground-based sensors, and then imagery. ION has already completed 23 missions, so this is not new, untested technology. The most recent went up on Tuesday with SpaceX Rideshare. This deal also had some involvement with the trading company Madhubeni, who helped arrange it. Next up is Elevation Space. They signed an MOU with Luxembourg's Space Cargo Unlimited for in-orbit processing. Space Cargo Unlimited makes a standardized, what they call a bento box, autonomous experimental interface. So the idea is that this would be integrated with Elevation Space's re-entry capsules for initial launch in 2030. This would create a end-to-end on-orbit experiment and physical sample return service that would be fully independent of the ISS or other commercial space station efforts. Elevation Space has been in the news a lot lately. They just recently raised a $40 million funding round and expect to have the next test flight of their ELSR re-entry capsule in 2027. And finally, Saturn, SSC Space, and Infostellar announced a partnership. Saturn a really interesting company. They were founded in 1889, so more than 130 years old, as a textile and industrial materials manufacturer, so back in the Meiji period in Japan. Over the past decade, they've been extending their precision weaving and advanced polymer technologies into the aerospace market. This led to them successfully launching their own small satellite into 2021, and then later development of a full-scale manufacturing pipeline for small satellites and synthetic aperture radar antenna arrays, a capability they've been developing with SPACETIDE. The new agreement is with SSC Space. SSC Space, if you are familiar with them, they used to be called the Swedish Space Corporation. So based in Sweden, just shortened their name. And Infostellar I mentioned at the top, they're just acquired by Mitsubishi Electric. Infostellar and SSC Space both provide ground station services. So this is aimed at enabling Saturn, when they launch their next satellite, which is called Fusion 1, to have ground station network that's necessary to transmit the images they capture in orbit back to Earth. And that is it for this week. If you like what you see, please like and subscribe, and you can also get regular news roundups and in-depth stories like this through the Japan Earth Observer newsletter by signing up at japanearthobserver.com. See you next week.